Hello, my name is Ramon Benavides. I'm with the MET Science Program at the University of Texas at El Paso. I'll be presenting to you Kilbourne Hole. This presentation is part of a series in which we will focus on key geological areas of the El Paso region dating back to 1.1 billion years ago to the present. We will cover Pelican Canyon, Orchid Mountains, Torrey, Pico Tanks, Sierra de Juarez, and Lake Cabeza de Vaca, which at its present day is part of Scenic Drive. The Kilbourne Hole is a geological gem. I'll begin the presentation by talking about the regional landscape. I'll talk about the La Mesa Basin and some of the contributing factors to the formation of the Kilbourne Hole, such as the Rio Grande Rift, the local faults, and the basaltic flows found in the area. Then I'll go ahead and talk about the formation of a Mar volcano, then get into the specifics of the Kilbourne Mar formation, then talk about the minerals and rocks found at Kilbourne, specifically the basalt peridotite ejecta. So let's get started. Kilbourne Hole is located in the southwest region of the United States. Found within the state of New Mexico, lies within the Chihuahuan Desert. It's northwest of El Paso, Texas, and southwest of Las Cruces, New Mexico. Kilbourne Hole is located in the southern part of the state of New Mexico. It lies within a basin called La Mesa. This basin was once part of the primitive Rio Grande before the river made its shift towards the east. As you can see in this illustration, the Rio Grande River once flowed through La Mesa Basin and drained into Lake Cabeza de Vaca before making its shift towards the east. This explains the river sediments found throughout La Mesa. In order to fully understand the formation of Kilbourne Hole, we have to look at the geological history found in this area. We have to go back to the late Mesozoic and early Cenozoic era, where we have the Laramide orogeny. Here we have the Phaleron plate subducting under the North American plate in a shallow manner, causing some deformation and volcanic activity in the interior portion of the North American plate. Then we move on to the middle and late Cenozoic crustal extension. Here we have two continental plates pulling apart, forming a series of faults and basins. This is known as the Rio Grande Rift. The Rio Grande Rift system is a continental rift system that is composed of a disproportionate system of grabens. Grabens are crustal depressions paralleled by faults. This rift begins in Colorado, runs through New Mexico, into parts of Texas and Mexico. The rifting process is caused by two plates pulling apart, depleting or thinning out the continental crust, allowing the mantle to get closer to the surface. And because of the faults located in the rift, this makes the continental crust brittle, allowing magma to flow through it and cause volcanic activity. This is evident in the area in which Kilbourne Hole is located. La Mesa is encompassed by a series of faults that cut through the flat basin. These faults were created by the crustal extension at the Rio Grande Rift. Here you have the Robledo Fault and the Fitzgerald Fault. Much volcanic activity has been found here, specifically a series of Mar volcanoes found along the Fitzgerald Fault. These Mar volcanoes are also known as Mars of La Mesa. We have the Portillo Mar, Hunt Mar, and finally the Kilbourne Mar. This volcanic activity is evident throughout La Mesa. We'll go ahead and concentrate on Aiden's Crater. Aiden's Crater was created by a shield volcano. This is the origination of these basaltic flows that encompassed most of the plain region. These basaltic flows were very fluid and traveled south, covering a good portion of the plain region, as can be seen in the outer rim of Kilbourne Hole. This layer of basalt ranges for about 4 to 5 meters thick. A Mar volcano is formed when rising magma through a feeder dike comes in contact with the surrounding water. This produces vapor, which then produces an eruption cloud made up of tephra. Tephra consists of tuff and sediments. This process continues until you have a massive hydrothermal explosion or a phreatomagmatic explosion, producing a large crater and massive amounts of ejecta. Within the next few slides, I'll be showing the formation of Kilbourne Mar. I'll be displaying a cross-section of the area. This cross-section is exaggerated to better describe what occurred at the Kilbourne Mar. This cross-section was created from other resources and references, utilizing other resources and references to better describe what occurred at the Kilbourne Mar. This slide illustrates the La Mesa Basin prior to rifting. This slide begins to show you the beginning of the rifting process. You have the Colorado Plateau pulling one way, the Great Plains Plate pulling another. You will start seeing the thinning of the crust and the rising of the mantle. This slide illustrates the Rio Grande Rift Formation. You have the Colorado Plateau pulling one way, the Great Plains Plate pulling another, an increase in the thinning of or depleting of the crust, rising of the mantle, coming closer to the surface. This is producing some volcanic activity in the area, which have produced these basaltic flows and have blanketed the La Mesa region. Here we have the formation of a dike, with the magma coming closer to the water table. As magma continues to rise, it comes in contact with water-saturated sediments, forming vapor. This vapor escapes to the surface. However, this process is impeded by the basaltic rock. The vapor escapes, forming an eruption cloud made up of tephra. This tephra is composed of tuff and sediments and falls out in the surrounding area and accumulates, forming tephra rings, which can be seen in these two photographs. The next few steps happen quickly. However, I'm going to slow it down a bit. So magma comes in contact with the water table, producing more vapor. Vapor that's trying to escape, but remember, the process is impeded because of the layer of the basaltic rock here. Not only that, we also start seeing the deformation of the adjacent country rock, forming some xenoliths here. Now the popcorn is popped. You have this huge hydrothermal explosion, this huge phreatomagmatic explosion, piercing through the basaltic overlay. The ejecta includes tephra, mantle rock, pieces of the basaltic overlay, country rock, sediments, groundwater. All this happens quickly. This crater is massive. It's about 3 kilometers long, 2.5 kilometers wide. Its floor lies about 100 meters below the adjoining plain. The rim is composed mostly of the basaltic overlay, and a good portion of it is made up of the tephra. This tephra is unconsolidated and is stratified, which includes segments or fragments of intrusives and country rock. The crater was originally deeper, but has been filled with the eruptive sediments and also with a runoff from the surrounding area. The formation of the crater occurred about 80,000 to 100,000 years ago. It was intense. It was completed through a series of events that happened quickly. The eruption brought mantle debris unlike other rocks found in the surrounding area. This Mars volcano released ash, country rock, basalt, and most importantly, xenolith with peridotite inclusions. Peridotite includes olivine. Here at Kilbourne Hole, some of this olivine is of gem quality, which is peridot. This is what makes Kilbourne Hole so unique. Here are some photographs of those lava bombs with the peridotite inclusions. As you can see here, there's a lava bomb. You have some peridotite. Here you have some country rock, some more of that mantle rock with small specks of peridotite. Here we have the Kilbourne gem. As mentioned before, peridot is gem quality olivine. Olivine can be found throughout the surrounding area at Kilbourne Hole. Many rock enthusiasts, rock hounds, some gem enthusiasts, some amateur gem enthusiasts come out in search of this peridot. Kilbourne Hole is one of a kind when compared to other Mars of La Mesa. It lies within this flat land where the primitive Rio Grande used to flow into southern New Mexico. It is a Mars volcano which formed by specific geological processes in the region. The formation of the Rio Grande Rift and the aft flows both contributed to Kilbourne Hole's uniqueness. With a crater resembling that of the Moon and its peridot gems, the crater is significant to the El Paso region's geological history. My name is Ramon Benavides. I'm with the MET Science program at the University of Texas of El Paso.